Hello, young math Padawans. It's Mrs. Angel with your lesson for today on an introduction to functions, specifically input and output relations, representing relations as a set of ordered pairs, a table, a graph, and a mapping diagram, and then finally describing the domain and range of different relations. A lot of algebra is the study of functions, linear functions, quadratic functions. So we want to make sure that we understand how all of these work before we start getting into more of those complex functions. So grab some notes and let's get started. So the first vocabulary word you're going to learn here is a relation. A relation pairs each input with a specific output. Think about how you are related to different people in your family. You're related to your sister or your brother in a different way that you're related to your aunt or your uncle. The same works in math. Each input has a very specific relation to its output. And then as we'll learn later on, some of those relations are also called functions. So what does this look like in math? Well, your inputs are almost always going to be represented as x. So think of an equation, maybe something like y equals 2x plus 1. The x in this case would represent any number that you want to input, and that's where the word input comes from. And that would produce what's called an output, which is normally your y value. So for example, like I said, if I inputted 5 for x here, 2 times 5 is 10, plus 1 is 11, which means that my output here would be 11. And that's how the two are, quote, related to each other. So what happens between these two is called the relation. So the reason why these are related is going to change based on the function that you're looking at, linear, quadratic, exponential, etc. So in our example here, we chose to input 5. Our relation was to multiply by 2 and then add 1, and then we had our output 11. So in math, you're going to see a lot of different representations of these relations. The first one we're going to get used to is called the ordered pair, or a coordinate x comma y. Notice here that there are parentheses around this. That's showing you that this is a very specific relation of input x and output y. So let's take a look at an example. Here I have a set of 5 ordered pairs. Can you give me the inputs and the outputs of these ordered pairs? Let's see how you did. So from left to right, I see that my inputs here are -2, -1, 0, 1, and 2. So I'm just going to list those out using what's called set notation. Set notation means that you use a squiggly bracket like this, and it's only those specific numbers allowed in those sets, kind of like an exclusive club for those numbers only. So my numbers were -2, -1, 0, 1, and 2, and then I'm going to close off the set. Those were the only inputs in this relation. My outputs here were 2, another 2, another 2, 0, and 0 again. Now, it seems kind of silly to list out the 2 3 times, the 0 2 times. We're just saying what was represented in our output. So in this case, there were only 2 numbers represented as our output, and those were 0 and 2. So I don't need to list them out over and over again to say that they were part of my output. Another thing that I did that you might want to take note of for later on in this video is I did order my inputs and outputs from least to greatest. So notice that I started with the least input and ended with the greatest input. Same thing, started with the least output and ended with the greatest output. Another way to represent relations is with a table. Now, the most common tables you're going to see are going to be vertical tables. However, you may also see horizontal tables. The x's, of course, are your inputs, and the y's are your outputs. Let's take a look at an example. So here I have a horizontal table, my inputs x on the top, my outputs y on the bottom. Can you list those inputs and outputs using set notation? Let's see how you did. So my inputs here are going to be all the values of x listed from least to greatest with no repeats. So my inputs here were -2, -1, 0, 1, and 2. Our outputs here are Y, and again, they are listed in order from least to greatest already with no repeats, so I can just write those out. So when we're listing our inputs and outputs, we're not specifically showing which two are related to each other. We're just identifying what they were for this particular relation. And that's representing relations in a table. The third and probably the most important representation of a relation is in a graph. You're going to see this a lot in algebra. So a graph, as we learned, is really just the intersection of two number lines. The horizontal number line going from left to right is your x value or your x-axis, and the vertical number line going from up to down is your y-axis. So how do you find inputs and outputs in a graph? Well, it's actually pretty simple. Your outputs are going to be whatever numbers are represented on that vertical number line, and your inputs are going to be whatever numbers are represented on the horizontal number line. So let's take a look at an example. Here I have a graph that already has 1, 2, 3, 4, 5, 6 coordinates in it. Can you list the inputs and outputs of this relation? Let's see how you did. This is a little bit tougher to see just from a graph of points. So one strategy is you could write all of these points as ordered pairs and then go in and identify the inputs and outputs. Here's a second way to tell. If I zoom in on this graph, I can see the inputs and outputs represented by each point. And I'm purposely going to go from left to right and bottom to top because I want to list those in order from least to greatest. So the first input that I notice here is for this point right here, and that has an input of -3. So I know -3 is one of my input values. It looks like this point here has an input of -2, this input at a -1. We have a point at the input of 0, and then nothing for a while, and then a point at the input of 3, and a point at the input of 4. So we just found our set of inputs. I'm going to go ahead and put those in our set notation.
-2, -1, 0, 2, and 4.
As we can see, they're already listed in order from least to greatest with no repeats. The outputs are a little tougher to read. Let's take a closer look. So again, zooming in here, I'm going to work from bottom to top so that I'm listing my outputs in order from least to greatest. So it looks like the lowest point here is this one right there. So let's take a look. This point has an output of -3, a y value of -3, which that's how I know that will be part of my output. This next point has an output of -2, no outputs at -1. We do have an output at 0 again. We have an output at 1, an output at 2, and an output at 3. So it looks like the only numbers not represented in our outputs are -4, -1, and +4. So let's go ahead and put those into our set notation.
-3, -2, 0, 1, 2, and 3.
And again, we didn't have any repeat values, and we listed our inputs and outputs from least to greatest. So this is what a relation looks like as a graph. The final part of this video is going back and describing each relation's domain and range. And that might seem like a lot of work to do, but here's the cool part. You've actually already done it because the domain of a relation is simply its set of inputs. And guess what the range is? Its set of outputs. So if you look back at all of our examples, we already have this. We were just calling it inputs and outputs instead of domain and range. So let's just go back to our examples really quick and relabel that using this appropriate vocabulary. Remember example 1 with our ordered pairs? Well, we can now say that the domain were the values -2, -1, 0, 1, and 2, and the range was 0 and 2. And now we've done domain and range. Same can be said for our example on representing a table. In this case, our domain was -2, -1, 0, 1, and 2, and our range was 3, 4, 5, 6, and 7. We already did all of that work. Here's our graph, and once again, that work is already done. The domain of this relation were the inputs, -3, -2, -1, 0, 3, and 4. And the range of this relation were the outputs, -3, -2, 0, 1, 2, and 3. Done. So just to recap, a relation is how each input is matched or related to a specific output. And whenever you are asked to identify the domain and range, just remember the domain is simply your set of inputs, and the range is simply your set of outputs. That's it for today's lesson. I will see you next time.